So what's porosity? Porosity's classical definition is simply just the fraction of a material's volume that's void space. And so if you think about that, here's an example again of a glass jar full of rocks. The porosity of this glass jar of rocks is simply just the void space volume, the volume that right now is filled with air over the total volume that is in this jar. And this is important for a lot of different reasons. One thing is that this porosity is the void space that can be filled with water in a groundwater system. And so if we think about something like this sandstone rock, why we care about porosity is we care about the volume of water that can be held between the sand grains. And there's a couple of different ways to measure porosity. I think the easiest example is to think about it something like this. So I have this beaker right here, and this beaker is empty, and I can pour into this beaker basically glass marbles. And so if I want to know what the porosity is of these marbles in this glass beaker, what I can simply do is I can determine on the side of the beaker the volume that represents these marbles. And then what I can do is I can take a glass of water and I can pour that glass of water into these marbles. And in that void space, that water will fill that void space. I can then measure how much water I poured in, and the amount of water, the volume of water that I poured in, over the total volume that these marbles represent, that they're filling, that's what the porosity is. And so and this doesn't just have to be with marbles, right? This could be with round marbles. This could be with flat marbles, like these kind of marbles they use for, I think, arts and crafts kinds of things. And so porosity is this idea that it's basically the percentage of rock that is void space. Okay, and so if we think about this, a lot of times we classify porosity. We talk about it in terms of the value of N. We use N to represent porosity, and N is equal to the volume of void over the total volume. And different rocks have different porosity. If you think about this, this sandstone has a fairly high porosity, maybe up to even 30%, 0.3. And this granite has a very, very low porosity. The interesting thing with granite and this very, very low porosity is that there is primary porosity, the void space, and there can actually be secondary porosity, like in a granite like this, where this granite may have a fracture in it. There may be the rock may split, and that split, that void space, is a secondary porosity. It wasn't natural in the rock. It was something that happened later on, and that porosity is where we can actually get water from. If you want to try some kind of cool examples with porosity, I actually have a little paper model, a little foldable aquifer model that you can calculate what the porosity is for, in this case, something we call cubic packing. And down below, what I'll do is I'll post a link to this problem. So if you would like to explore what porosity is and measure the total the volume of void space over the total volume in order to calculate porosity. It's kind of a fun activity to do, and it gives you a little bit of idea of kind of what porosity actually looks like and how we can actually calculate porosity, because it is important, because porosity in aquifers tells us something about how much water that aquifer can store. So with that, think about these examples when you think about porosity. Think about primary porosity and secondary porosity, that porosity with fractures. And then if you want to do something quantitative, try out one of these little foldable aquifers and give your hand at calculating what porosity would be for cubic packing. Again, if you have any questions, please let me know. I'm always happy to answer them.